யாரையும் ஒதுக்காதே, உன் பணியை ஊக்கமுடன் செய், வாழ்வில் வெற்றி பெறுவார் என்ற பொன்மொழிகளோடு இன்றைய நாள் சிறப்பு விருந்தினராக அண்ணா பல்கலைக்கழகம் கிண்டியிலிருந்து உயர் திரு ஐயா அவர்கள் பி. நிர்மல்குமார் ஐயா அவர்கள் சிறப்புரையாற்ற வந்திருக்கிறார். அவர்களை நமது வேல்டெக் தொழில்நுட்ப கல்லூரி நிறுவனத்தின் சார்பாகவும் மின்னணு மற்றும் தொடர்பியல் துறை சார்பாகவும் 2ஆம் ஆண்டு மாணவர்கள் சார்பாகவும் வருக என வரவேற்பதில் நான் பெருமகிழ்ச்சி அடைகிறேன்.
And what are the topics till now they covered for you? Anyone? Electronic circuits. I think it is off the way of the semester. I think they covered what topics they covered? You tell me what topics they covered. Power MOSFETs. JFET. Okay, no problem. Started. Okay. I think before that, electronic circuits, how it is? What? Complicated. Is the thing is really easy? No. Why? See, basically, I came here for not to teach you. Okay. I think it is there in the book, I know, and if you put the search, Google, and you can take what are topics you need, and lot of more question papers there you can study. Here, why they calling Well-Tech, first you must know why they are coming here. So we came here to not only to discuss about subject, you have so many ideas with you, and you don't know how to express that, and you don't know how to study, because we are only framing the syllabus. Our department only framing the syllabus for your affiliate colleges. So what are doubts you are having, whatever things in the mind, you can have some discussion, and because you can come and meet me. If you come and meet me in your department, I am available. Just ask my scholar also is there. Okay? You can ask, you can't meet any professor nowadays. It's difficult to meet them because there are a lot of other administrative work. That's why only this Well-Tech has given some opportunities to invite some professors from university so that they can interact with you. Not only subject, anything you want, you can discuss electronic products. So this kind of electronics analysis, there in electronic devices, to study only the operation of the device. Operation of the device. Operation of transistors, operation of FET, or what is the Ebers mode model, and what is the current equation, or what is the drift current, what is the drift current, what diffusion current. That's my idea. Yes or no? So, idalam parchacha. This and all we have studied. Now we are entering into electronic circuits 1. Application. You see, now itself you know the demand. How much demand is there for PC? It is not so easy. Now also there is a demand for engineers. You think that sir, engineers, this admission is very poor like that. Don't think like that now. The industry needs only the resource persons. What are something he can't able to teach you in the industry. Go to the industry, he will not train you. You must learn the analysis. For example, electronic circuits. What type of software is used for that? What type of software they are used? What type of software you can use for electronics for this design? If you want to design here, fixed bias circuit. I think biasing is there. Biasing what's in that? Then study biasing. If you want to design a circuit or any device, what type of software is there? The software required. Just tell anyone. What type of software is there for designing the circuits? You are doing manually in the lab. Practically you are doing in the lab. Lab na pandrom. PCB edutittu, that is we just cutting the components and inserting, and we are setting the characteristics of the device. But nowadays the industry we are not going to do the practically. They are going to do only the, that is in the analysis by the software, because whatever you are studying, it's only 20% of the industry needs. 80% industry is different. There we need to study only the tools, how to design these circuits by using the tools. Which book you are following for this? Nowadays, you see, in other book nowadays, if you go and buy any book, there will be a CD. CD there the software will be there. Some book they will give, you don't know the name of the software. Software is what type of software is done for designing? I think you will learn the electronics lab, you do know. So for example, here in the third semester, you have to try to learn about PSpice. What is PSpice software will do? PSpice software is there. As the student level version is there, you can go and take that and you can design the transistors and you can analyze whatever they are doing in the lab. It can be done in the system itself and you can see verify your result. So like that, the industry is like that only. So now itself, from the beginning itself, you must know that all types of, for each semesters, some kind of software you should update. Some sort of software you should update. It may be a MATLAB, it may be PSpice, it may be any tool of which is nothing but VLSI. That is, VLSI is the next advanced of electronics. So tell me now, any doubt? Anything you want to ask? So as I told, electronics has a wide range of applications. So the electronics has, we can't limit the applications. We can't limit the applications of electronics. We have washing machine, TV, that is a consumer electronics, home appliances. All the TV, DVD, whatever they are using in the home, or washing machine, or in the micro oven, or the fridge. Nowadays, if anything repaired, the iron box repaired, what are doing? Electronics inside the coil will be there. Anything happens, any fault occurs, there is no problem. Which a small example I'm telling, iron box. What nowadays you are doing? Replace. We are not going to repair that. We are just replacing and buying a new one. Because the cost has been reduced. Repair 1,000 rupees. If you go and give any repair shop, it's charging more than the new one. For that you can go and buy for new one. The cost has been reduced because of the advance in the electronics. You take a mobile phone. Mobile is an example. Mobile has all kind of applications. You can do wireless communication. You can do whatever you want to do. You want to chat with your friends, or if you want to interact with your friends anywhere in the world, at any time. Anywhere in the world, at any time, you can interact with your friends, or if you can talk to your parents, whatever you want. Nowadays, very cheap also. That is the communication. Because of communication, advance the communication, now all the products has been cheaper. Now, mobile is a very issue. While I am studying, if anyone bring one mobile to a college, it's I think it's a very big industry person, or he is having a lot of money like that. Now everybody having the mobile. We think 5 phones. Still networks. How networks will have this kind of applications? How to connect them? You will know so. How the complexity of the structure. In the campus, I think more than 500 houses are in our campus. All are calling and the network is connected. Why I am telling means, even the small circuits you are filling it tough. Small is nothing. Whatever you see, I think today I covered about the male V JFET amplifiers and kind of MOSFET. These two topics only I am going to take. But you think that industry complexity, complexity of circuits, that we have to analyze. must study the basics, how to analyze the circuits. See, while I am studying also the same biasing, fixed bias, voltage divided bias, and what is called to base bias. Same till now, we are the concept of the transistor is same. So anyone you tell me what is the disadvantages in the transistors? Why you are going for FET amplifiers, FET transistors? Anyone? First we are studying about transistors, then we are going for FET. So tell me what is the main advantages? Transistors, I think you know. I just have put the slides, I just run that. Just a discussion only. You must know now. So, say, if you see nowadays you know, you have to prepare for a gate. Gate they will not ask theory and all. It's only a probability. It's only a probability. You must know the concept. Which book you are following for this electronic circuits one? Joel. Then why is Sullivan, Joel? Sullivan and Kelly Potter, Joel Kelly Potter. Then see, you must buy any one of the book given in the reference. Seen that they since syllabus syllabus kid book போட்டுருப்பாங்க டெஸ்ட் புக் போட்டுருப்பாங்களே என்ன புக் they given யாரும் பார்த்துக்க மாட்டீங்க என்ன புக் see Donald Newman okay அந்த புக் வாங்கி படிங்க these are discussions you know that you study about Sullivan அது எக்ஸாம் ஒண்ணுமே வராது okay so theory means no problem if they ask that question means you can solve the problem but the study is Donald Newman or Sarah Smith will be a reference about number. Any one book you buy, you can buy Donald Newman, it will cover all the 4 years for you. The 4 years in the advance for you, or in the future also. If you have any doubt, you can refer that book. So please student, try to buy that book. At least ask one book. Then only you can understand why we want to study electronics, what is the concept of electronics, and what is the need. You can design pannada theriyum. Otherwise, it's really difficult. Sullivan, but the exam kandipa kekka maatanga. Moreover, you can't get a good mark also. You can't learn electronics. So my exam time la, you study and you will wrong it and you will forget it. That's all. That's mechanical by pannalam, but you can't. So you must buy either the Sarah Smith. Before that, that is test book. Sarah Smith is the test book. Now they change to Donald Newman. Any one book you can buy and you can study. Now you tell me what is the difference between transistor and their FET? Anyone? I think the sir also teach in the class. Girls, tell me. You must know. You must aware of that. Why you want to go for transistors, FET? So the boys, anyone? Just tell no, nothing wrong. I can judge whatever you know. Yeah, correct.
Transistor doesn't have a transistor has a electrons flow to one while FET has a gate system where there's no compression.
It's not like that, correct only. But what he's saying means, whatever the point he told, BJT is a current control device. That is, the input will give the voltage and we are controlling the output as the current. So BJT means it is a bipolar junction transistor. You know, bipolar means the conductions of the conduction means the current flow. The current flow in the circuit. Current flow in the circuit will be by both the electrons and the holes. Both by electrons and the holes. Whereas in the FET field, there is a field, we are calling it a field, is a voltage control device. So applying the two input, the current and controlling the voltage. So FET is a voltage control device. They will ask in 2 marks, define or state the difference between a bipolar transistor and a field effect transistors. And one more point what you telling means, that is the same, we are having the gate. Here in transistors, we are having the 3 terminals. One is a base, emitter and a collector. So transistors will transfer, that is the low resistance part to high resistance part. That is the operation. There is the current flow from the low resistance to the high resistance part. Where the FET comes. FET is a unipolar device. That's only we are calling as a trans resistors. It transfers the resistance from low to high. Transfers. Trans resistor. That's why calling as transistors. Okay. So transistor means it transfers the resistance from low to high. FET is a unipolar device. The current will be only by any one of the, that is either by electrons or holes. It is a P channel means, and we are having N channel and P channel. The channel is nothing but a silicon bar. We take a bar, if it's a N channel, it is made up of electrons. It's a P channel means it's by holes. Okay. So the current flow from, so the operation is very simple. And one more advantage why you are going for FET now. FET means it has high input impedance. All applications we need only the high input impedance. BJT has not, it has not having the high input impedance, but output impedance will be high, but input impedance will be low. Impedance சொல்றாங்கல, student game about impedance. Impedance will be more. High input impedance for FET. FET amplifiers has high input impedance, whereas in BJT it has low input impedance. So FET and one more important thing why we want to go for this FET means the capacitance effect, that is plays a major role in our design. If design பண்ணி வச்சீங்க, நீங்க output input கொடுத்தீங்கன்னா அந்த output கரெக்ட்டா வராது. What is the basic purpose of a transistor? நான் சொல்லுங்க முதல்ல பாப்போம். What is the basic purpose of a transistor? நம்ம எதுக்கு transistor யூஸ் பண்ணணும்? Switch, okay, switch. Transistor can be as a switch, correct? That amplification, yeah, that is very important. My signals to be amplified. My signals to be, that's why they are giving the electronic mic, loudspeaker. They are given mic to amplify my signals. Since the color memories I can have, this I hold in my hand. So it is a, I am not feeling good. See the my sophistication. The advance I need some color mic. Nowadays the industry, you know, nowadays we are living in the next generation. We want also to life. By yesterday while studying the office, they are going to office nowadays. After completing your PG, definitely everybody will get job. So what we'll do, we'll be working in the office. While going to home, I want to switch on the AC. I want to my room as chill. But a hot of all the AC borrow. Then inside our home, inside getting into our home, the AC should be on. That you can do by using a small app. Nowadays it's developed now. In your office, you can give the instruction to switch on your AC. But everything is automated. Before that, for example, if you take EV some areas they will come, but in our areas they are not coming. Everything is updated in the online. He will take the record from his office itself. He will have some kind of instrument, communication device, which will tell these are the things for your meters. You have to pay the money. So this is the electronics. Next all flats, all house what I am going to buy, it is everything is automated. Lock smart applications. The closed door automatically will be locked. In future, if you see, it's going to come. In future, all things. That's what I'm saying. Without electronics, no one can design. Can anyone tell me how much processor will be there? For example, in any of the cars, you take any cars. I saw outside also some Volkswagen standing. You can see, just go and see how much electronics are used in automobile applications. Lot of products are used. So you must learn about this kind of electronics fundamentals thoroughly. If you take any Audi car or BMW car, more than 50 to 80 processors are there. So each one will do some task. For example, if any action happens, it has with the airbag perfectly. And controlling the speed also. Controlling the speed. Nowadays they are going for ABS. Ellame electronics da. Once happening, everything. And whatever the AC, say temperature. Ellame it has kind of electronic products. So it's up to you how you are inside the campus. In the campus la 4 years, every person will be going low. Adamula future la you will be sitting in the top position. If you are wasting here, then it's totally waste for you. You study electronics, sit in the lab, try to learn some kind of software which is useful for you. Only that. Then, as I told, you, electronics, lot of opportunities there, and especially the FET amplifiers. And one more advantage is why you are going for FET means, that is especially FET, JFET and the MOSFET. Transistor, it dissipates more heat. Even though giving your friends to your phone for 30 minutes, 20 minutes, some phone will get heated. Some, if you buy some Samsung phone, for 10 minutes phone will get. I am having a Motorola phone, for 10 minutes it will be heated. The power dissipation is more. Okay, it may be a transistor, a kind of mass device, but its heat is more. It's giving more heat. That should be reduced. Minimize parano. And the processor will get hanged. So MOSFET wire going means MOSFET occupies less power. The battery it should come for, nowadays Apple phone itself comes for 2 days. Charge pudamiye, we can talk up to 2 days. You think about the battery, how they design the battery. So MOSFETs is mainly used, that is FET is mainly used nowadays in IC design. Entire circuits, whatever you are studying doing in the lab, ICs if you take digital circuits, the digital is going next semester I think so, or this semester I don't know. All gates, digital logics, ICs or IC741 or IC, different ICs will be there. Digital gates, logic gates, or so mainly the ICs, the size is very, we can have more number of devices in a MOSFETs comparing with the transistors. That's only they are going for VLSI. So VLSI is nothing but the mass applications. I think you know about, if you take a small example, I'm telling how much complexity is there here while designing a design. What type of processor are you using in the lab? Computer processor is computer processor. What kind of processor? Maybe a Pentium 2, Pentium 3 or 3 and 2 points. Now we are going for 3, 4 or i3, i5 like that we are going. Dual probe, i7 like that we are going. See, it is nothing but it has that kind of transistors inside the device. It should do more applications. I think you know about Eden Garden. Eden Garden, you know Eden Garden. Cricket match of father king la. Nowadays no match playing in India. I think Eden Garden, you know that with ground you take a small ant. Take ant. If we fill the full ground of ants. It is each one is a transistor. That is the processor design. That kind of transistor has a one processor. So think about that. How much transistor is there? Millions of transistors can be fabricated in the small device. Laptop, everything, how complex we are. To take some small iPad. All the applications we are doing. What other company is going to do? The device, a big device. That can be done by the small iPad. That kind of complexity device, transistors can be fabricated in small IC. So the main advantage going for mass is the power it consumes less and the capacitance effect. The capacitance effect is very less compared with the FET. Why you can ask, sir, why already FET is there? FET is JFET. Junction, field effect, transistors, and they're going for MOSFET. Metal oxide, field effect, transistors. You may have aware of doubt. Sir, why you want to go MOSFETs? Comparing with the FET, MOSFET has no input impedance, better as well. Input impedance high and the capacitance is also very less comparing with the FET. So only all are going for mass. And moreover, mass is very easy. Transistor is have more number of equations. Okay, JFET, but mass has only the two regions. One is the saturation region, is the triode region. Only two ID, drain current. ID is the drain current. You know, we'll have the two regions in the MOSFET. And the operation is also very simple. Any doubt on this why you are studying electronics? What is the difference between BJT and FET? I think all the
Input impedance should be high. So why input impedance people see as
see if you want to go for high domain applications, I want to start in capacity between high. The car is speed for the slow company. So why are you going for BMW car and all? Starting from 0 to 5 seconds, it goes 100. So it should be, torque should be, input will be high. Slow for Sandro car, slow down. For example, say, for light electronics, it needs high input impedance. Current so that the power should be high. Mobile phone message message WhatsApp message it should reach immediately. You should not go 2 days afterwards. So all devices needs high input impedance, especially in electronics. Okay. See, as I told, FET is a unipolar device. I will just remind that. And now, what is the need for biasing? Biasing, I think you have studied. Biasing, see, biasing is very important. Biasing a circuit, not only this biasing concept are used in transistors, it is used in MOS also. MOS biasing, FET biasing. What is the need for biasing? I put a question like this. Biasing per singular. So tell me what is the use for biasing? Biasing is circuit. This syllabus biasing is not of transistors. So transistor I told it is two classifications. One is the PNP, other is the NPN, and transistors main application is amplification. The signal to be amplified and lot of devices use these transistors. So you must know the operation of transistors. Okay. So the current, what is the current? It is IE or IC output. IC is equal to RIE. Limited current, collector current. Collector current. The base current will be very small. The base current will be very small. So you can say IC is equal to IE. Okay, the base current will be very small. So we can take the base current. You can say IE is equal to IE. That will show you. Tell me the கேட்டப்ப you tell me what is biasing? Biasing என்ன? என்னமா சொல்லுங்க girls? What is biasing? See, this is all you must know. நம்ம எதுக்கு biasing படிக்கணும்? Not only in transistors, it is used in mass also. For any product, electronics எடுத்தீங்கனாலே you must aware of should do biasing. நடத்திட்டாங்க biasing. சொல்லுங்க it is supply to the junctions. Yeah, what is saying means it will give supply to the junctions. Any other answer is there?
There will be a region where it functions with less distortion and high capacity. So we do a bias circuit so that we force that component to work in that outlet.
Yeah, whatever is saying is somewhat is correct, but he is telling that what you understand. You know that transistors will operate in the three modes of regions. What are the three modes? One is the active region, saturation region, and the cutoff region. These are the three regions of operation any transistor will do. Any transistors will do. But if you bias a transistors in the cutoff region or in the saturation region, my signal will not be amplified. What is the purpose of transistor? It will not be done. When you listen to a transistor, you are designing as amplifier means it will amplify signals. They are going for multi-stage amplifiers nowadays or cascade amplifiers. Combination of two amplifiers. They increase the gain. The output is their gain. The output is your gain. They are finding, I think you have studied about small signal models. Particularly small signal models, H parameters. Studied about H parameters, hybrid parameters. Where and all, we are analyzing the transistors as a two-port network. Two-port network. We are taking a transistors, they are giving the input, that will give the output. That is, the input is nothing but the is designed. It is designed from circuit theory. Designed from your circuit theory. It is the Thevenin's theorem. The input is nothing but your Thevenin's theorem, and the output is nothing but your Norton's theorem. The components to the two-port network has been developed. And we are analyzing the transistors by using the H parameter analysis. What is the input impedance? What is the output impedance? What is the current gain and voltage gain? That can be replaced by any type of configurations. See, once you derive for the simple generic applications, then it can be replaced by a common base, common emitter and common collector. Only the rotation will change. Base na V ponno, emitter na E ponno. Collector means C ponno. That's all. Same concept can be, if you study that hybrid models, this can be implemented directly. Again, data AI is equal to HOE, some equation will come. I forgot that. Current gain AI is equal to H22 or H12 by output will write. So it can be HBE for base, like that we will replace. And this same thing can be formula of data, we can calculate the current gain, voltage gain. So we are forming the general. So biasing is the fundamental. For a transistor, it should operate banana, it should be biased first. That is called as operating point. The biasing, another name is operating point or Q-shaped point, Q point, where the voltage and current will meet. And if you draw the load line, we are telling about DC and AC load line. DC and AC load line. Both the biasing, if you done the biasing means the DC load line and the AC load line. Voltage current voltage current. If you draw the graph, load line, AC load line and DC load line, the biasing should be done at the center of the operating point. That is the load line. It should meet at the center of the Q point, where your VGS Q and ICQ will meet. Voltage and current will meet that point. So biasing panna, the purpose of this transistors will not be used. Transistors will not operate in the active region. So the output is distorted. So sine wave with the sine wave varano. If you are giving a sine wave, it should come as a sine wave. That will come only in the active region. It will do proper biasing only. Otherwise, some part of the signal will be flipped, either positive or negative. Sine wave, my signal should be come. The harmonics, what I observed the pi means, it should come. That's only studying about filters and all. I think we study about filters also. Half-wave filters, full-wave filters, capacitor filter, inductor filter. First you will it will be there in electron circuits. Rectifier, yeah, rectifiers that is calling as full rectifier, half-wave rectifiers, capacitor input filter, choke input filter, like that. So we are removing the harmonics by using the filter circuits. The output should not be distorted. We are going for regulator voltage supplies. The AC we are having stabilizers which will give the constant voltage to the load. Otherwise, automatically my component, that is my device, will get damaged. So biasing not only in transistors, it is used in FET and MOS also. And nowadays they are going for analog device, analog amplifiers, analog filters. That is implemented. Before that it was implemented only by transistors. Now everything is replaced by MOS circuits. Analog device, analog and digital. There are two devices there. Okay, one is the analog and digital. But real world needs only the analog output. Analog output. Whatever we are doing, real time we need only analog, not digital. We need only the analog, not the digitals. So you must aware of what is analog and digital. Nowadays it is mixed. Analog and digital is mixed. They are calling as mixed signal. Mixed signal analysis, mixed signal device or RF signals, which has the analog components. Radio frequency components, it has both analog and digitals. All antenna, mobile, wireless communications, it has both. So electronics, so all are replaced by MOS devices, MOS circuits. In MOS also, we must need of biasing. So biasing means they are fixing a Q point so that the transistors will operate in the active region. And everything you should meet at the center of the load line. So now just what I told, just read that. See why we are going for, before that, small signal and high signal, and we are studying about two models. One is the small signal model. Okay, small signal model and high frequency model. Two model படிப்போம் syllabusல பாத்தீங்கன்னா one is before slide. We will study about small signal analysis of MOSFET or small signals of transistors. Just note down everything. Okay, note down because whatever you see you will forget. Whatever points I am telling it is covered. I read from so many books and I am telling. Otherwise I can't speak more. Okay, so you just remind this and you note down all the points so that if you study from the book, it will be useful for you. Small signal or high frequency model. There are two models in there. Low small signal model and a high signal analysis. One is small signal, other is the high signal analysis. The small signal analysis is used for low frequency methods. If you are going for low frequency analysis, the small signal is used. Okay. If you are going for high frequencies, that is pi model is used. Other high signal analysis. You have to study both. You study the both. That's why only you are studying for frequency analysis. You have to study low frequency and high frequencies analysis. So small signal analysis is nothing but it's used in the low frequency of the device. And moreover, the parameter is only low frequency analysis, not for high frequency analysis. So, today we are going to or Sarah's method. I think I go to library. Library lot of Sarah's method kind of electronics. So differential amplifier is very much important because most of the applications are using this concept. So you must see whether they ask using, you must study differential amplifier using CMOS and FET, which transistor they are using, ask. That you have to put, draw a diagram and derive the derivation. Electronic circuits are it's only derivations and problem. So biasing first you the biasing. So biasing they will ask, draw the define the what is meant by biasing or derive the definition for voltage driven biasing. Mostly they will ask voltage driven biasing and there is some problem. For that there is no need to study the problem. Just to study the operation of the biasing. Biasing operation, then you know how to apply the loss. How to apply the loss. It's more than enough. You study the Kirchhoff's current law and voltage law, and if you are going and the problem will be easier. And moreover, answer is not important. How the steps, not getting the proper answer also, it is solved thoroughly. Applying Kirchhoff's law and input loop. Draw them neatly. Applying the Kirchhoff's output loop. I is given, I is the data, and some mistake also they give marks. And so again, but they will not give marks. They will give only and moreover, you will not lose the marks. So like that only to get good marks. Exam fixed bias, draw circuit diameter. This is a fixed bias. Okay, here the input is fixed. Apply the Kirchhoff's law. Write the base current equation. Write the voltage equation. From there we correlate. Get the data. What is beta? Current amplitude factor. IC by like that you write data, and if you solve it, definitely it will be easy for you. Okay. So circuit theory, but you know, then analysis. How they are writing the data. That is very much important. So next is the JFET, MOSFET, JFET and BiMOS. So BiMOS is equal to the next topic. So this I told, this is skip transistors. This is my water point I told, this is data. These are nodes. Okay. So the current conduction is by both the carriers, whereas in the FET it is the unipolar device. It's by only by the majority carriers. Next. So as I told, it is classified into two types. One is the NPN, other is the PNP. So other point is that is note down. Next one. This is a symbol, you know. One is the, sometimes they will draw wrongly. The arrow mark indicates which is NPN, which is PNP. Okay. Arrow mark indicates which is NPN, which is the PNP transistors. This operation is not needed. Next. Electron devices. So here if you see, there are two types of bias. One is the forward bias, one is the reverse bias. This is the operation of PNP transistors. Next. So this is the previous slide. This is the three configurations. One is the common base, common emitter and common collector. So depending upon the which is common, base common or base, emitter means emitter. So this is the characteristics of the device. One is the input characteristics or is the output characteristics. The input means it is the base voltage and the current, VB and IV. The next. So go for filter. So this is the current amplification factor. This I told the previous slide. It will operate in the three modes of regions. One is the active region, cutoff region and the saturation region. They will ask the two marks, what is current amplification factor, what is beta. It is defined by change the current by change the base current. This is the equation. This is the MOSFET. So MOSFETs having two classifications. One is the enhancement MOSFET and the efficient MOSFET. Depending upon the what type of voltage you applied. If the positive means it is enhancement mode. So most of the industries they are using this enhancement mode MOSFETs. So MOSFET has the operation is very simple. If you see, we are having the source, drain and the gate. Okay, source, drain, and this is a symbol of the MOSFET. Source, drain and the gate, and this is the diagram for the MOSFETs. Okay, so we are having okay, we are having a P channel and two heavily doped N regions. At the top, we are having a SiO2, silicon dioxide layer, which will act as a insulator. Okay, and by applying the voltage, the body is called a substrate. The body and the gate is grounded. It's called the substrate. Is showing. See here, W by L is very much important in the MOSFETs. Okay, W by is the width and the length. W by is the width and the length. So MOSFETs are used as a current steering circuits also. Current steering circuits and all, as I told now, in analog or digital circuits, we can design a processor as a microprocessor by using the ICs. I think you will do microprocessor and study microprocessor. The microprocessor kit we can design by using the ICs, by using the MOS. We can fabricate, as I told now, an example hidden on ground, more than millions of transistors in the IC, which dissipates less power. That's important. Heat is minimized. Power dissipation is less. MOS, then we are going for CMOS. CMOS is the combination of NMOS and PMOS. So why you are going for CMOS means here also the power dissipation is less. Comparing the MOS, it takes only less power. Analysis is different, but theoretically the power is less and the capacitance effect will be less compared to the MOSFET. So the operation, as I told, applying the gate voltage, they are forming the channel first. Then apply the voltage. Then they will control the source to the drain. Okay, electrons will flow from source to the drain. Current flow will be opposite to the flow of electrons. Next one. And this is the operation they are given. First you have to apply the voltages from the channel first, then apply the voltage to the source, so that if it is the voltage between the get to the source, current flow will be there from the source to the drain. Electrons will flow and current flow will be in the opposite to the device. The same thing, P channel. Next. So these are diffusion type MOSFET. Okay, diffusion type MOSFET. So see, here if you see, whatever we are going to study for FET, same is for MOSFET. Same number, same calculations. Okay. Only thing is, we are writing the analysis, okay, by using the linear equations, Shortly's equations. The interaction between the characteristics and the linear characteristics defined by the MOSFET or the transistors. And this is the analysis. Analysis we see that is analysis. How to analysis? Okay. First, note down this. First, we see what type of network is given. What type of network? The problem you must see. Analyzing a MOSFET for this analysis, you must see what type of network you see. Then find the gate voltage. What is the gate voltage? That is, we combine this is a voltage you are biasing. That is 110 megaohms R1. Here 10 megaohms R2. Combine these two most happening as 1 megaohms. It is R1 parallel R2. That is for input impedance. R1 parallel R2. So find VG and VGS. Draw the linear characteristics. Then the transfer characteristics. And obtain the Q point. And obtain the operating point. Operating point is nothing but the VGSQ and IDQ. VP is the pinch off voltage. If they're going on increasing the voltage, at some point both will touch each other. That time there will be no control. That they are calling as pinch off voltage. Increase the gate voltage. The channel will increase. The channel will increases. At some point both will touch and it goes to the pinch off voltage. I think they covered about JFET, no? JFET, you studied about devices. Analyze they covered for you, no? Common source, common gate and the common drain. It will act as a transistors, it will act as a, before that it will just go to FET. FET to so this will come for FET and come for MOSFET, so that easy for you. Go for FET. See JFET if you see, as I told, we are having three basic configurations. See, this is the derivation, so that we see JFET is has three configuration. One is the common source. They will ask 2 marks. What are the three configuration of the thing? One is common source, common drain. Third one is the common gate. Common drain is also called as source follower. Source follower. And this is a difference. This I told. Difference between the BJT and the FET. So now we will see about the small signal. It's visible for you. Yes, handwritten notes. Visible for you. Last boys, now if you see the small analysis. So the drain to the source voltage, that is the VDS. The drain to the source voltage of FET. The drain to the source voltage, you know, the JFET has three terminals, source, drain and the gate. The drain to the source voltage current of the JFET is controlled by the gate to the source voltage. Gate to the VGS and VDS. Okay. The change in the current due to the change in the source voltage can be determined by the transconductance. There are 2 marks. Define transconductance. So that is nothing but the change in the dead current. Symbol put a symbol. Change the ID by changing the VGS. That is called as transconductance. So usually this mostly for 60 to 80% they will ask 2 marks. Define transconductance. So it is nothing but the change in the drain current due to the change in the gate to the source voltage is called as GM. Next one. And this is the, take it down, this is the AC equivalent model of a JFET for common source. If you see here, the gate to the source is open. Input is open here. How we are drawing the small signal model? The 2 model draw the small signal model of JFET. If you see here, the AC equivalent circuit, so this program data lines, that is the transistors. You see here, they have drawn the small signal equivalent model AC circuit and then draw as a lines. That is they act as a transistors. That is any devices is operated as a open device. That is gate to the source and output getting as drain to the source. So input, if you see what the input is applying, it is gate to the source voltage. See, you get FET the next MOSFET promoting. So study thoroughly about FET. Then you go for MOS. Same calculation what AC equal circuit. Otherwise, not worry about diagram. Okay, you try to draw the equal circuit. So that, next one. So if you see the same circuit, there that R1, R2, okay, that R1, R2 has been replaced, and this is a JFET. This is a JFET with self bias. I'll show the common source sequence circuit. This is the previous slide. This is the JFET self bias. JFET self bias. and that is the AC equivalent circuit. As I told, the input impedance ZI is equal to your RG. RG is nothing but your R1 parallel R2. That you are taking as RG. RG is that this here. And the output impedance. Output impedance is nothing but seeing the diagram, the equivalent circuit. Okay. If you see the VGS, the current amplifying factors, everything is same. One thing is they are adding the RD, the parallel there, and that is your capital RD is nothing but your drain resistance. Next one. And applying the Kirchhoff's law. So any of diagram, just go to the previous. Okay, you see this diagram, you see this derivation diagram. Draw the diagram. So draw this JFET with self bias. Or we'll see for common source itself. We'll see for common source put it draw one over. We'll see for common source. We'll see for common source. Wait. This diagram drawn now. Common source. Put the equivalent for common source. Go to this. Next one, last one, common source. Next one. Source, amplifier. Common source, amplifier is this. Draw diagram. Common source, amplifier. Draw the equivalent circuit. It's R1, R2, and RD is there. RD is your drain resistance. RD is your drain resistance. If you see the equivalent circuit, I will read. Okay. First one is R1 parallel R2. For R1 pointing there, it is R1 parallel R2. Next is nothing but GM into VGS. GM into VGS. And that is what RD and R0. RD and R0. So now applying Kirchhoff's law. Now applying the Kirchhoff's law, we can tell right now. GM minus GM, the current flow. Why I am putting minus means the voltage and the current are flowing in the opposite direction. The minus means the current and voltage are flowing in the opposite direction. So we are putting as V0 is equal to I into R. That is minus GM into VGS. That is R0 parallel RD. That we are taking as first equation. So second equation, if you see the input at the source voltage, the input at the source voltage VI. It is VGS by R. VGS by R. V by I. Okay. So that is where from equation 2 we can write what is VA. You calculate what is the input impedance, what is the output impedance. Check the answers. You calculate, just apply Kirchhoff's law and you calculate what is the different parameters. What is the voltage gain? What is the voltage gain? It will be minus GM into VGS RD naught parallel RD. See, apply Kirchhoff's law at output loop. Apply Kirchhoff's law at output loop and you try to calculate. So as I told, it's only analysis. It's only analysis. And clear enough, but you try to calculate now. You try to calculate what is the voltage gain? AV. What about the AV? See, what is voltage gain? Output by input. Output by input. Just calculate what is the output, what is the input for common source amplifier. I have given the diagram for you. I have given the diagram. See, like this, they will ask the problem also. Common source, they will ask problem. We have to draw a circuit diagram and we have to write the equation voltage gain. And you can calculate. I think it clear. It is R0. See, I read the output voltage given by V0 is equal to minus GM VGS R0 parallel or to same thing. V is equal to I into R. You see what is R? R is nothing but R1 divided by R1 plus R is RI into RI into that's all. Taking as RI. RI divided by RI plus RS. RI plus RS, that's all. RI plus RS. Into BI. Into your BI, input voltage. Next you can BI. See, this is not clear, but in here you try to find out. So that is RI by BI is equal to VJ divided by RI divided by RI plus RS. Try to calculate what is the voltage gain. From that you can find what VGS. See the equivalent circuit. Next to Baba. See V0 is the output voltage. As I told, V0 is equal to I into R. V is equal to I into R. Our output as you see it is IS into R will be RS parallel RL. V is equal to I into R. Output output voltage is equal to IS into RS parallel RL. IS already we calculated is GM into VGS into RS parallel RL. That you can write. And input as VGS plus your V0. VGS, V0 already we calculated. From that you write what is V0. Okay. From that you can find what is the voltage gain. So the voltage gain of any common drain amplifier is equal to 1. The voltage gain is approximately equal to 1. You get approximately is equal to 1. See VI, if you see what is the input voltage VI, it is nothing but a combination of V0, that is R0 plus where VGS. From the equivalent circuit. From the equivalent circuit. From that you can find what is the voltage gain AV. So the AC output voltage usually will be 1. Will be given as 1. See all FET, what I was saying, it is used in MOSFETs also. MOSFETs also is used. MOSFETs we are going for current steering circuit concept. That is like as a current mirror circuits. That is whatever the current mirror means as a mirror image. Whatever the input current plus the output current. So I1 is equal to, that is ID1 is then current is equal to ID2. There will be no loss in the device. There will be no loss in the device. So we are going for next design, that is your multi-stage amplifiers and the cascode amplifiers. Cascode means combination of two transistors. Now it is the gain. Gain is not sufficient to drive the load. For that, we are going for cascode combination of two transistors. Okay. So like that, we have to go and mass also exists. So mass amplifier mixed relation to the output is there. We are seeing about this is the mixed this common gate diagram. Common gate is one diagram. Diagram for this to calculate. This for common gate circuit analysis. Draw diagram for common gate also. Common source, common drain, and common gate. Common gate is common. So the input is separated between source and the gate. The input is separated between the source and the gate. You draw the common gate, and the output is into drain and the gate. Common gate. See, like exam point of view, the third unit of, they will ask by CMOS or common source, common drain, common gate. Amplifier is another. And different amplifier, especially all the 5 you see, they will ask biasing they will ask. And you can tell, you know what type biasing you will ask. Biasing question around. Next if you see common source, common drain, common gate. You can report amplifier. Especially most of the questions they ask common source. Common source or drain follower. Sometimes they ask common gate also. We don't know which they will ask. So you must aware of all the circuits and you know how to draw the equivalent circuit. Remember that and try to find out the different parameters like input impedance, output impedance and the voltage gain, current gain, everything you have to calculate. This for common gate. Yeah, electronic circuits applications tremendous as I told, kids were told. This for common gate. Common source, common drain and common gate, transistors and amplifiers. So stop getting doubt and ask them. Let it go now. What they told electronics as all applications, analog, digital, signal, all applications are having. Just study the electronics thoroughly. This is as the beginning itself. If you book just study at the beginning itself. So that it will be useful for all your coming years. Now next year also they are going to see. You study the Kirchhoff's law, of communication mathematics. Next year you study about all types of communications. Signal processing. Signal system processing already. Next you study about digital signal processing. Yes. Next semester, full semester. Everywhere if you see, it's only mathematics now. So here if you study thoroughly only, that will be easy for you. If you lag almost everything will be lagging for you. That's all here. Thank you.
இந்த பல்துறை பொருளை முன்னிலையாக கொண்டு தனது பொன்னான நேரங்களை எங்களுக்காக ஒதுக்கி எனது கல்லூரியின் மாணவர்களுக்கு அறிவுரைக்கூடிய ஐயா அவர்களுக்கு எனது கல்லூரியின் சார்பாக நன்றிகளை தெரிவித்துக் கொள்கிறேன்.
Thank you, Pastor. See, we just see the question paper also. In question paper, this question will be there in the website. A lot of website is there. Mostly if you see, they will check from the previous question papers. That is a model for you. Just see 4 question papers. It will be very easy for all subjects. Just type 4 question papers. What are they asked? You see the question paper. Syllabus will change. Okay? Syllabus will be, question will be from repeated only. But the mass must be thoroughly. Mass down into something. Part C, I think they may ask the problem. Compulsory 15 marks. Part C, what they will ask means, they will ask some analysis. Because all are getting 80 marks, 90 marks. There is no difference between the two. What they think means is depending on setters. Setter question paper problem or theorem or they ask some analysis. But it will be within syllabus only. It will be with syllabus, but we don't know which question will be asked in the part C. Before that, you have to put it on. Correct? Now, you can't do it. எந்த யூனிட்ல வரும் நமக்கு அந்த மாதிரி இல்ல ஒரு யூனிட் தான் வரும். ஒரு யூனிட் with data that you have to design the MOSFETs for using the depression MOSFET like that. அதெல்லாம் புக்ல இருக்குதா, புக்ல ப்ராப்ளம் கொடுத்து சேஸ் புக்ல பாத்தீங்கன்னா some problem கொடுத்திருப்பாங்க. Design oriented problem will be there. Some design oriented problem they will ask. நீங்க யோசிச்சு டிசைன் பண்ற மாதிரி கேட்பாங்க. If you have luck இருந்ததுன்னா டிஃபரன்ஸ் செட்டர் நான் செட் பண்ணா கொஞ்சம் பாஸ் செட் பண்ணுவேன். பசங்களை பார்த்து ஓகே சேனல் இப்படி தான் இருக்கும் லைக் தட். But if you study thoroughly 5 minutes, completely நீங்க answer பண்ணிடலாம். Nothing to worry about policy. It's nothing but some how to differentiate between எல்லாருமே எஸ் வந்துடுறானுங்க, எல்லாருமே அட்டன் பண்ணிடுறாங்க கொஸ்டின்ஸ். அதுவும் getting the answer sheets nowadays இன்னும் ஏதாவது மார்க் விட்டா கூட can go for re-totaling or re-counseling, that is re-evaluation, get the marks. எல்லாத்துக்கும் 890 போட்டு not able to differentiate. So what they introduce means there is part C which really the test the engineers. அது வந்து யோசிச்சு போடுற மாதிரி பண்றதுக்கு பண்ணிருக்காங்க அவ்வளவுதான். But it will be from syllabus only. But we don't know which unit they will ask. அது வந்து சென்டர் பொறுத்து மாறும். பட் அஞ்சு யூனிட் எதுனா கேட்கலாம். பட் மோஸ்ட்லி அந்த ப்ராப்ளம் தான் கேட்பாங்க, தேதி கேட்க மாட்டாங்க.
அது வந்து சில ஆப்ஷன் இருக்குல்ல, இப்போ வந்து கேஸ் ஸ்டடி இந்த மாதிரி காம்பனன்சி டைப் வந்து பார்த்தீங்கன்னா சாய்ஸ்